Hello everyone, in this video we'll be doing the CBSE Class 9th Maths Chapter 1 Orienting Yourself, the Use of Coordinates. This is as per the new syllabus of NCERT following the new textbook Ganit Manjari. Let us get started. Till now we have only seen a one-dimensional number line where either a number could move left or right from 0 and we could locate its position. But what if a point lied above or below this number line? How do we determine its location and everything beyond that? For that, we use a 2D Cartesian coordinate system where we place two number lines perpendicular to each other, where the horizontal axis is called the x-axis and the vertical axis is called the y-axis. And the plane in which these axes are situated is called the Cartesian plane or the coordinate plane or the xy plane. And any point in this xy plane is given by the x and the y coordinate accordingly and written as x, y. These axes divide the plane into four parts which are called quadrant. The first quadrant where both the coordinates are positive. In the second quadrant, x coordinate is negative and y coordinate is positive. Third quadrant, both the coordinates are negative, and fourth quadrant where the x coordinate is positive and the y coordinate is negative. Let us see how we locate a point in this coordinate system. Let us start with a point on the x-axis. Let us say A. The coordinates of this will be given by how many units of x has the coordinate moved, which is 5 units, and y is 0 because it is on the x-axis. So hence the coordinates of A will be 5, 0, which is similar to the x, y. Suppose if the point is on the y-axis, then the coordinate will be 0, how many units it has moved on the y-axis, which is 3. So 0, 3. If it is in the xy plane, let's say a point C, then we write the number of units of x, which is 5 units of x, and the number of units of y, which is 4 units of y, 5, 4 as the coordinates of C. Similarly, if we move to the opposite side on the x-axis, the point B could have the coordinates minus 6, 0, and the point E in the second quadrant will have the coordinates minus 9, 4. Similarly, F will be 0, minus 4, G will be minus 10, minus 6, and H would be 8, minus 2. This is how we write the coordinates of points in the coordinate system. Request you to try these points and try to label their coordinates. You can write the answers in the comment section below. Moving on to finding the distance between 2 points in a coordinate plane. In a 2D plane, let's say we have 2 points A with the coordinates x1, y1 and B with the coordinates x2, y2. How do we find the distance between the 2 points A and B? Now we can use Pythagoras theorem here to help us find this distance. We can make this AB a hypotenuse of a right angle triangle with the right angle at C by drawing so. Now we know that from the y-axis, A has moved x1 units and C has moved x2 units. The distance between A and C will be x2 minus x1. Similarly for B, the distance will be y2 minus y1. Hence, we can say that the hypotenuse is given by the sum of the squares of the sides, square root of x2 minus x1 square plus y2 minus y1 square. This is the distance between the 2 points x1, y1 and x2, y2. Let us see how this distance is calculated for these points. So A is at 3, 3 and B is at 7, 6. Substituting the values in the formulae, we can write that AB is equal to 7 minus 3 square plus 6 minus 3 square, which is equal to square root of 4 square plus 3 square, which is square root of 16 plus 9, which is square root of 25, or AB is 5 units. That is how we determine the distance between 2 points in a 2D plane. Let us solve some questions from the exercises of the textbook and see how we can use distance formula in multiple situations. And this is the question number 6 in the end of chapter exercises. So there are 3 points, M equals to minus 3, minus 4, A equals to 0, 0 and G equals to 6, 8. Are the points M, A, G on the straight line? Suggest a method to check this without plotting or joining. So let us see how we derive this formula. If 3 points are in a straight line, which let's say ABC, we can say that the distance from A to B plus the distance from B to C should be equal to the distance of A and C. So that is how we can determine if three numbers are on a straight line. So question number 7 asks you use this method that you have used in problem number 6 and check if they are all RAC are on the straight line. So let us find the distance between R and B. So using the distance formula, it would be minus 5 minus of minus 2 whole square plus minus 1 minus of minus 5 whole square. That would be minus 3 square plus 4 square, which is equal to 9 plus 6 root over 25, which is 5 units. Similarly, RC would be minus 5 minus 4 whole square plus minus 1 minus of minus 12 whole square, which is equal to minus 9 square plus 11 square, which is 81 plus 121, which is equal to root over 202, which is 14.21 units. Let us check the distance between B and C now, which is equal to root over minus 2 minus 4 whole square plus minus of minus 5 minus of minus 12 whole square, which is minus 6 square plus 7 square, which is equal to 36 plus 49, which is equal to root over 85, which is 9.21 units. As we can see that RB plus BC distance will be equal to the total RC distance, we can say that all three lines are on a straight line. This is how you use the distance formula to determine if 3 points are on a straight line. Moving on to the example number 10, where we need to use the distance formula to find out the midpoint. So using the connection you found, find the coordinates of B given that M minus 7, 1 is the midpoint of A, which is 3, minus 4, and B is given by X, Y. So how do we find the coordinates of X, Y is, if M is the midpoint, it has equal distances from both ends. That is, AM will be equal to MB. And the change from A to M, same change will occur in M to B. So if the X coordinate change from A to M, which is minus 7, minus of 3 is equal to minus 10. So the same change should occur in M to B. So Y coordinate changes 1 minus of minus 4, which is equal to 5. So to find the change that should occur from M to B, the X coordinate will be minus 7 plus the change that we saw earlier, which is minus 10, which is equal to minus 17. And the Y coordinate change from M to B would be again 1 plus the 5 that we have seen, which is equal to 6. So the coordinates of B will be minus 17, 6. We can verify this using the distance formula. So let us find the distance AM, which is equal to root over minus 7 minus 3 whole square plus 1 minus minus 4 whole square, which is equal to root over minus 10 square plus 5 square, which is equal to root over 100 plus 25, which is equal to 1 square root of 125. And MB distance will be minus 17 minus of minus 7 whole square plus 6 minus 1 whole square, which is equal to root over minus 10 whole square plus 5 square. So again 100 plus 25, which is equal to root over 125. So AM is equal to MB, hence our coordinates of B are accurate. Now moving on to the next question, example number 5, where we find out if the points lie on a circle. Given the points A, B, C as such, show that they lie on a circle K whose center is the origin 0, 0. What is the radius of K? Given the points D and E such, check whether D and E lie within the circle, on the circle, or outside the circle. So, what is the thing that we know about circle is that the radius is constant from every point on the circle to the center. So, if the distance from the center to each of the point is equal, then they all lie on the center. So let us find out the distance one by one. So OA, O being the center. So that would be 1 minus 0 square minus 8 minus 0 square, which is equal to 1 plus 64, which is root over 65, 8.06 units. Distance from OB, which is also coming to root over 65, which is 8.06 units. And OC, which is also coming to root over 65, which is 8.06 units. Since the distance from the center is same, they all lie on the circle and the radius is 8.06 units. Now to solve the second part of the question, we will check the distance of the point from the origin. If it is equal to the radius, then it will lie on the circle. If it is more than the radius, it will lie outside the circle. And if it is less than the radius, it will lie inside the circle. So again, distance OD is given by square root of minus 5 minus 0 whole square plus 6 minus 0 whole square, which is equal to minus 5 square plus 6 square, which is root over 25 plus 36, which is equal to root over 61, which is 7.81 unit. And OE, the distance, would be equal to 0 minus 0 whole square plus 9 minus 0 whole square, which is square root of 0 square plus 9 square, which is root over 81, which is equal to 9 units. We can see that OD is less than OA or any of the radius that we have. Hence, this point lies inside the circle, and OE is greater than the radius. Hence, it lies outside the circle K. Well, this completes your chapter, Orienting Yourself Using the Coordinates. Request you to complete all the questions in the exercises and comment below if you have any problem with any question and we can solve it here. Until then, subscribe to the channel and watch other videos of CBSE Class 9th, and see you in the next one.